The MRT Purple Line, Bang Yai to Bang Su section, is part of a comprehensive extension of the mass transit network in Bangkok. The project is split into 3 contracts. This presentation concentrates on Contract 1. Contract 1 starts with an about 1 kilometer long extension of the existing MRT Blue Line, running from Bang Su to Tao Pun Station, which is the interchange point with the Purple Line. At Tao Pun Station, one ascends 1 level to enter the Purple Line. The alignment of Contract 1 then runs along Krungtep Nonthaburi Road for a distance of about 5 kilometers before it turns into Tiwanon Road. It follows Tiwanon Road for another 1.5 kilometers and then turns into Ratana Tibet Road, where it ends after another little less than 4 kilometers. 8 stations are included in Contract 1. In addition to Tao Pun Interchange Station, another 3 stations are located along the Krungtep Nonthaburi Road. In Tiwanan Road, one finds the Ministry of Public Health Station, while the final 3 stations are located along Ratana Tibet Road. In the following, an alternative to the original design of Contract 1 is presented. The alternative does not include any change to the first part of the original design, but starts at the end of the structure over Klong Prem, where the viaduct begins. In the conforming bid, all stations are designed with platform located at the center, serving trains in both directions. Each station has 3 levels and spreads along 8 bays of 36 meters each. In the alternative design, all stations have 2 levels and 30-meter long spans. 3 of the 8 stations are designed with side platforms. Side platforms allow straight track alignments through the stations with improved riding comfort and reduced wear between rail and wheel. However, the required width of stations with side platforms is larger than for stations with central platform, and an alternative central configuration is therefore used for the other 4 stations along Tiwanon Road and Krungtep Nonthaburi Road, which have narrow right-of-ways. A main difference between the original and the alternative station design is that while the original design comprises 3 elevated levels, concourse, mezzanine and platform, the alternative has only 2 levels, the concourse and the platform level. The vertical distance between concourse and platform levels is reduced by 1.5 meters for stations with central platform and 3.15 meters for stations with side platforms. Tao Pun Station is the only station where the configuration in the original design has been maintained. At the ground level, the alternative design is fully within the right-of-way of the original design. This applies both to stations with central platform and with side platforms. All station entrances in the alternative design are at the original location. The outline area of the concourse level for the alternative design, both with central and side platform, is approximately the same size as in the original design. The service level of the alternative design is equivalent to the standard used in elevated stations of the BTS and the MRT Blue Line in Bangkok and mass transit systems in other countries. The platforms in the alternative design are designed for the same train length and same ridership as in the original design. Side platforms may be completed for 4 cars only in a first stage and lengthened to accommodate 6 cars in the future when ridership increases. Savings from such possible stage construction would include 120 meters of passenger screen doors at each station and some finishing. Central platforms have to be constructed to ultimate capacity from the beginning. The station roof is designed to meet the preference of MRTA, which says, stations shall be bold in concept, of attractive appearance and easily identified by corporate image. Station forms should have identifiable Thai character. The character of the alternative roof design is inspired by the banana leaf, which may represent Thai spirit and Thai way of life. It is something Thai people know well and use on many occasions throughout their lifetime. Its straight form matches with the station form. The concept has been adapted to architectural form. The roof form looks like 3 banana leaves overlapping each other. Tiers are covered by skylight. The alternative station serves passengers and operation staff with at least the same level of comfort, efficiency and safety as the original station. Ancillary area for staff and E&M are shown in green, area for public in yellow. Paid area in yellow, unpaid in red. In the alternative design for stations with central platform, passengers who descend at the wrong end may move from one part of the concourse to the other at the same level. To save cost, the number of lifts has been reduced from 2 to 1 in the alternative design for stations with central platform. Emergency stairs in the original design are located in staff area and open to passengers in case of emergency only. In the alternative central platform design, these have been open to public to provide faster descending. Side platform provides shorter distance to the stairs and easier alighting. The descending escalator in the original design has been replaced with stair, and the original stair is widened. This graph shows the size of total public area, total support area and roof area in the original design compared with alternative side and central platforms. Here we have a comparison of boarding circulation speed between the original central platform design and the alternative side platform design. First in elevation, and then in plan. And this is a comparison of alighting circulation speed between the original central platform design and the alternative side platform design. Again in elevation and in plan. The alternative stations are designed according to the latest version of the NFPA 130 standard. A Comparison of emergency evacuation speed between the original platform and the alternative central platform is shown here. Compartment walls are highlighted. And here with the alternative side platform. The typical viaduct in the original design is a box girder simply supported span by span with depth 2.6 meter and maximum span length 40 meters. The typical alternative viaduct is a 3-span continuous box girder with depth 2.0 meters. Maximum span configuration is 35, 40, 35 meters. The weight of the alternative viaduct is reduced by about 30% compared with the original design. This considerable reduction in weight enables substantial savings in foundations and dimensions of piers and portal frames, including many columns founded on single piles. In addition to the reduction in piling works and large pile caps, the single pile solution makes the differential settlement reduction structures redundant. Totally about 40% of the piers in the Contract 1 alternative are founded on single piles. The viaduct in the original design has a movement joint marked MJ for every second span and link slab marked CJ at piers in between. At every pier, the superstructure is supported by 4 bearings. The typical alternative viaduct has a movement joint for every 3 spans. It is supported by 4 bearings at piers with movement joints. Intermediate piers are monolithically connected with the columns and no bearings are required. Consequently, the number of movement joints and bearings are considerably reduced in the alternative design. Generally, the centerline of the horizontal alignment follows the alignment of the conforming bid. However, along Ratanatibet Road from Yak Nontaburi until the alignment turns into Tivanan Road, the centerline has been moved slightly to follow the median of the road underneath. Along this section, a total of 10 cantilever columns, 12 portal frames and 33 T columns have been replaced by single columns founded on one pile. In addition to the savings in cost, the removal of cantilever columns and portal frames benefits traffic management during construction and has permanent positive aesthetic and environmental impact. The alternative design has several benefits. Huge savings in construction costs, smaller in size but still sufficient and less intrusive, safety up to current standard, less power consumption, less construction time, lighter superstructure reduces piling, 40% single pile piers, no need for large pile caps, reduced traffic management during construction. Superstructure continues over 2 and 3 spans, in line with recommendations in modern design codes, less depth and increased inherent safety. Reduced number of cantilever columns and portal frames, aesthetical and environmental improvement. More slender columns and portal frames, aesthetical improvement. Stations with side platforms allow a straight alignment through the station, better riding comfort, reduced wear between rail and wheel.